everyone, welcome to Factor 4 located on the BCIT Burnaby campus. Today we're here to talk about energy and energy management while looking at an industrial dust extraction system. So what you have behind me is the biggest component of our system. It's connected to the first building you see behind me where we teach cabinet making, so our joinery department. And it's also connected to a second building that you can't see behind where we teach carpentry. So from an energy consumption point of view, the old system consisted of 6 different units, which were all individually equipped with a fan. The conversion is that we went from these 6 units to only 1 unit that you see behind me and only 2 fans. So the process in a nutshell, you have the fans extracting both air, dust and shades from the building. All of those elements will go through the fans into the separator where actually the dust and the shades will fall into a conveyor. The air will be exhausted through the outlet and the conveyor will bring in the dust and the shades into the collection bin that you see at the bottom. So the old building covered dust extraction and shades extraction in 2 different buildings with 6 different fans located at 6 different points around the 2 buildings. The advantage of going to one location with a system like this is that it's easier for maintenance staff to come and empty the waste bins full of dust and shades, but also what we get out of this system is actually fuel that can be used to heat our buildings. So another project in Factor 4 is to build around this facility a biomass waste to energy facility that can generate hot water that can eventually be used to heat some of our buildings. So 2 ideas behind one location point, one collection point, making it easier for maintenance and building for or planning for a future biomass waste to energy system. So the component that is visible behind me is actually the motor. Remember that the fan is actually located in the box that you see just behind the motor. So now we're here today to learn about energy and energy management. What makes this system really energy efficient? Well, there are actually 3 reasons. The first one, and I'll tell you a bit more later when we're inside, but the sizing of the fans or the sizing of the motors is very important, and we did a very good job at keeping the size to a minimum for this project. The other idea is that you want to make sure you have an efficient motor. In this case, we have high efficiency ratings for these motors. And the third thing is you want the fans to rotate at the speed that you need. And for that, we decided to go with a combination of 2 variable frequency drives that are helping the system adapt to the true need. And again, I'm going to tell you a little bit more about that when we go inside. So as you can see behind me, we have many workstations, about 150 of them. And not all of them are used all the time. Students are making drawings, are doing prep work. They're not necessarily generating dust. So the first thing we did when we started this energy efficiency project is think about how we could design a system that would generate dust extraction only when needed. So the main driver of energy conservation for this project are our variable frequency drives, which I will show you later, but that are basically devices that change the frequency of the current, which means that it also changes the RPM of the fans, which means that it only extracts the CFM needed, reducing energy consumption at the same time. I'll give you a bit more details about this later. The old system that we had was a constant volume system, which means it had no VFD drive, no variable frequency drive, which means that it was either on or off and designed for all the workstations to be in use at the same time. So most of the time we were over extracting dust, which means we were overusing energy as well. From an energy conservation point of view, another very important element of the design of the new system, also showing the importance of having an integrated design team at the table, is the size of the fans and the size of the motors we selected. The older system was designed so that you could extract dust at 150 workstation. And while we were doing the design of the new system, one of the instructors here in January reminded us that the maximum capacity of this building is for 64 students. So in other words, these are very specialized workstation. You don't do the same type of work at each of them. And so you need 150 different ones, but there's no way you can get all of them running at the same time and all of them producing dust or shaves. So that allowed us to reduce the size of the fan and reduce the size of the motors so that our overall capacity is for plus or minus 64 workstation. We wanted to have a safety factor, so we went up for a bit more than 64 workstations. But downsizing the size of the motor means that we're using less energy when it's operating. This is a very good example of how you can conserve energy. With the old system, which was a constant volume on or off system, there would be dust extraction happening right now at this workstation even though no one is using it, even though no dust has been generated. With the new approach, what we have is a CT that is attached to the main feed to the workstation. The CT is the little green box that you see up there. The CT is actually sensing if there's a current, in other words, sensing if someone is using the workstation. And if that's the case, there's a signal that is going to be sent to our central panel that will do two things. It will open the gate that is driven by an actuator so that there's actually an opening in the duct attached to this workstation. And it will also send a signal to the VFD saying the fan needs to rotate at a higher speed because there's a new workstation needing dust extraction. So in simple terms, the new approach to doing dust extraction is on demand only. Only do extraction, only run your fan at a high speed if you need it, and if you don't need it, slow down the speed, save electricity. What you see behind me from left to right are the VFD drives and the control panels for the system. We have two VFD drives, two variable frequency drives, a large one for our 50 horsepower motor, the motor and the fan that is running the dust extraction for this building, and a smaller one for the 20 horsepower motor, 20 horsepower fan that is actually doing the dust extraction in the neighbor building where the carpentry program is delivered. You got to remember that in this system we're saving a lot of electricity because we have high efficiency motors, we have the right size for the motors, but the biggest component of our savings come from the fact that the consumption of electricity in a motor is proportional to the cube of the RPM. And so if you can lower the speed of rotation of your motor by changing the frequency, you can save a lot of electricity. We are now done with the tour of NE2 and the new Factor 4 dust extraction system. This was our first project that we've implemented as part of Factor 4. It's been running for more than 2 years now and considered a very successful project. We thought we would save about 80% of energy with our conservative estimates. We're actually saving closer to 90%. The system is very quiet. Instructors are saying it's making NE2 a better learning environment. Everyone is happy and we're now looking at the future. Hopefully the next time you come in this area, you'll see our new biomass waste to energy system in place, converting the shaves and the dust and the offcuts into heat for our buildings in the winter.